In this lesson, we are going to look at quadratic factorization, quadratic equations actually, where we're only going to factorize and solve. So these are the basic straightforward ones, the common ones that you would find. Now in the first example, we have the following. Now this is, you should be quite familiar with this by now if you're in grade 11, but even more so with quadratic factorization, because I'm not going to go into much detail about factorization, but it does consist, the most part of the sum when we solve for quadratic equations consists of quadratic factorization. And then just also to note, these examples will only contain equations that has like the easy type of quadratic factorization, not the harder, the XL method where there's a coefficient in front here. There's another type of factorization that you apply there. So make sure that you are confident with that. If you can't do that, then this lesson will be very hard. Alright, so now also there might not be in the examples, but there are in the exercises. There are some with harder type of factorization. Okay, so first of all, we factorize. And this is the easy factorization, so we basically take the factors of 7. 1 times 7 is the only factors there. So to get negative 6, I'm going to say minus 7 plus 1. Okay. Then I just take that and I put it in its factors, x plus 1 and x minus 7 equal to 0. Right, so now we have these two factors and they both equal to 0. So what we're going to do now is, since the product of these two factors are equal to 0, it means that either x plus 1 equals to 0 or that x minus 7 equals to 0. And then we can just solve for these independently. So we're just going to say x is equal to negative 1 or x is equal to 7. Now in example 2, now when we have these and it's not equal to 0, I've seen this quite a few times where people would just say x minus 3 is 18 or x plus 4 is 18. That definitely does not work that way. You have to multiply these brackets out and then put it in standard form. And remember, our standard form of a quadratic equation is ax squared plus bx plus c, where a, b, and c are variables, equals to 0. So we're going to put this into that form. Now we start off by foiling out the bracket. So we have x squared plus 4x minus 3x minus 12. And then I'm also going to bring the 18 over to the other side. Minus 18 equals to 0. Because remember, when you have a linear equation, you have all your x's on the one side and your constants on the other side. But when you have a quadratic equation, all the terms come over to the one side and you equate that to 0. Okay, and then if we simplify this, x squared plus x minus 30 equal to 0. So now we have a being 1, b is 1, and c is negative 30. Okay, and once again, factorizing this, factors of 30 is 1 times 30, 2 times 15, and 3 times 10. And also 4 can't go in there, and then 5 times 6, and then 6 is already there. Now to get plus 1, we can use 5 and 6 because the difference of them is 1. So I'm going to say plus 6 minus 5. If it was minus 1, we'd say minus 6 plus 5. Okay, now we just write it in its factors, x minus 5 equal and x plus 6 equals to 0. So x minus 5 equals to 0 or x plus 6 equals to 0. And then x is equal to 5 or x is equal to negative 6. Alright, next example. Example 3. Now we have fractions, and our goal is always to get rid of the fractions because they complicate things. So I'm going to treat all of these as factors, okay? Factor x plus 1 and 2 minus x. And to get rid of the fractions, we need to get the lowest common denominator between these, and that would be x plus 1 and 2 minus x. Okay, so that contains something of everything. And there's two ways to now get rid of the fractions. The one is longer, and it feels, for some people, I think it feels just like safer, where you would get everybody over the lowest common denominator, so you'd multiply top and bottom with 2 minus x, multiply top and bottom with x plus 1, multiply top and bottom with 2 minus x. Then once everybody is over the lowest common denominator, you can drop the denominators and you'll just work with the numerators. But I think this method is a bit easier, or faster actually, and that is just when you have found the lowest common denominator, you multiply each and every term with the lowest common denominator. So I'm going to multiply that, x plus 1 and 2 minus x, and then x plus 1, 2 minus x, and then multiply by x plus 1 and 2 minus x. Now what happens when I multiply everything with the lowest common denominator, because the lowest common denominator contains everything in the denominators, it would obviously cancel and all the factors would cancel. So this is x plus 1, they cancel. Then we are left with 2 minus x minus 6. This 2 minus x and this 2 minus x cancels. 6 times x plus 1 is left, equals to x plus 1, and then you're left with 2x plus 4 and 2 minus x. Okay, now we are going to multiply out the brackets. So we have 4 minus 2x minus 6x minus 6 equals to, and then we FOIL this out, 4x minus 2x squared plus 8 minus 4x. Okay, and where's our x squared? We had 4x minus 2x squared. There we go. Alright, and then we are going to take everybody to the one side. So this goes over to this side and changes sign, becomes 2x squared. Then everything that has a x in it, okay, obviously these two will add up to 0, so we don't have to worry about them. Minus 2 minus 6 is negative 8x. Then 4 minus 6 is minus 2, and then this comes over and it becomes minus 8 equals to 0. Okay, just simplifying that further, minus 8x minus 10 equals to 0. Now we can simplify this by, if we look at this, all these values are even, so we can divide every term with 2 to simplify our equation further. This would leave us with x squared minus 4x minus 5 equal to 0. Okay, and then factors of 5 is 1 times 5. So I'm going to say x minus 5 and x plus 1 equals to 0. So x equals to 5, or x is equal to negative 1. Example 4. Okay, so these are quite irritating actually, but when you get the hang of it, not too bad. So this, just notice that this is to the power of 1. Okay, and before I do that one, I'm just going to write down one that has the same coefficient. So let's say we had k squared plus k minus 6 equals to 0. So if you were to factorize this, basically you would say k plus 3 and k minus 2. Okay. Now here we notice also that this exponent is double that exponent. Now whenever that happens, you have to look at, okay, we have 3 terms, we've got 3 terms, and is this exponent double that exponent? And it is, because if you say a half multiplied by 2, then you get 1. So you can actually just rewrite this as x to the power of a half squared plus x to the power of a half, I'm going to put this in brackets, minus 6 equals to 0. So now you can actually just treat this as if it was k, or yeah, whatever you would do with k, you do with x to the power of a half. You can actually, even if it makes it easier for yourself, replace it with k, so factorize it, and then just put it back, replace k again with the x to the power of a half. But I think if you just carry on like this, then you'll have x to the power of a half plus 3 and x to the power of a half minus 2 equal to 0. So same, now continuing, x to the power of a half plus 3 is equal to 0, or x to the power of a half minus 2 equals to 0. Okay, and if we solve that, we start with taking the 3 over to the other side, negative 3, and x to the power of a half equals to 2. And now, to get rid of this, the easiest way is to just square it, square both sides. So what I do on the one side, I do on the other side, and we square it because when we look at our laws of exponents, when I multiply these exponents, they will just become 1, and I'll be just left with x. So let's say you had maybe x, anything, a over b, and that is equal to something, let's say 2. To get rid of that a over b, all you do is you just put it to the power of b over a, both sides, b over a. Then that would cancel, and you'd be left with x equals 2 power of b over a, 2 to the power of b over a. So yeah, this one, we just square it both sides, and then we have 9. On this side, we do the same. That's just squared, squared, so x is equal to 4. Final example. Okay, now here we have this guy that's hanging around here in the bottom, and I want to get rid of my fractions. So this is actually our lowest common denominator, or I can just think of, let's just multiply each term with that, multiply with x to the power of a half, multiply with x to the power of a half, multiply with x to the power of a half. Now the first term, so when I multiply the same basis, I add the exponents. So if I say x to the power of a half multiplied by x to the power of a half, then it becomes x to the power of half plus a half, and then it becomes x to the power of 1. So this is actually just x, and then that is just 3x to the power of a half, and this one just cancels top and bottom, so you're just left with negative 4, and that's just 0. 0 times x is just 0. Okay, now this is again where we were in example 4, where this is to the power of 1, so I can rewrite it as x to the power of a half squared, okay, minus 3 x to the power of a half minus 4 equals to 0, and then we can factorize that. So x to the power of a half, now factors of 4 will be 1 times 4 to get negative 3. I'm going to say minus 4 and x to the power of a half plus 1. That would give me negative 3. So x to the power of a half is equal to 4, or x to the power of a half is equal to 1. So I square both sides, and then x is equal to 16, or squaring both sides here, x is equal to 1.